we're going to talk about different classifications of numbers. Our first group is natural numbers. So basically, this one is the one that's most familiar to you, and it's the one that you learn first. Otherwise known as counting numbers, where you just count up from 1 to 10, but it basically goes on forever. So it's a set of all positive numbers. It's positive that start from 1 and have no fractional or decimal part, which means that they're whole numbers only. Now we're going to move on to our second set of numbers, which is whole numbers. Whole numbers are all natural numbers plus 0. Basically easy. 0, 1, 2, 3, 4, ... Number 3, integers. It's a whole set of numbers including negative natural numbers. Okay, so basically, we have positive numbers, whole numbers to be more exact. We have negative, whole numbers, and we have 0. This is integers. We have rational numbers, and these are all sets of numbers that can be written by dividing one integer by another. And it's just any number that's a fraction, a ratio, anything. So it can be 0.33333, and yep. This means that it goes on forever. Yeah, these are also rational numbers. -8. Yeah, I mean, it's classified as an integer. So basically, rational numbers are the big part. And natural numbers, natural whole numbers, and integer numbers, they all are classified in rational numbers. Okay. So basically, we're also going to talk about other numbers like irrational numbers. And you already guessed it's probably the opposite of rational numbers or outside of it. And yes, it's the set of numbers that are not rational numbers, so basically the opposite. And if we were to say that this whole blob, whatever you'll call it, is real numbers, which is every number inside, then irrational numbers, what color should we do it, guys? Purple. Okay, sure. Irrational numbers are over here, irrational. Then rational numbers would be over here. So they're basically in different areas, but they're both still real numbers. Back to our definition. These are numbers that cannot be written by dividing one integer by another. Like, for example, like root 5, let's say. It's like 2.236 06 7977 ... Or like pi, like it goes on forever. 3.141592653. And yes, there's a lot of people out there who memorize this. I don't really know if it's like really like necessary to memorize it, but I didn't memorize it because I was pretty curious about it, and I found some patterns. Well, not really patterns. So basically these ones don't have patterns. Unlike 0.3, which has a pattern of a 3. Okay, now real numbers, which is like the most important because it's just every number. Real number are ones that can be on a number line. So what about this one? A plus B, I. I is imaginary number. We do not consider this as something that is part of these real numbers because they're just imaginary numbers. I equals root minus 1. So I squared equals minus 1. I power to the 3 equals minus I power to the 4 equals 1, and I power to the 5 equals minus I, and etc. Wait, guys, I'm sorry. I power to the 4 equals plus 1. And it goes on so forth and so on like that. So basically, these numbers are just outside of the territory. Yeah, they're just outside. They're just external. Outside. Okay? So, let's move on to our next important points about some decimals. Terminating decimals. This is really important, guys. These are decimals that have no repeating digit or group of digits, which means that these are rational numbers. For example, 0.47. It ends, right? It doesn't go on forever, like 0.4723561, blah, blah, blah. This would be considered as repeating decimals, but only if it is like 0.4723561 and then 4723561, and it goes on like that. And basically, the bar over the digits means that all of those digits repeat infinitely. So I can just go like that, which means that it would like repeat infinitely, and this one would be classified as repeating decimals. Okay? Terminating decimals are things like 0.47, and repeating decimals are things like that go on for infinity times, guys. Just remember that, because terminating decimals, they don't have repeating digit or a group of digits, and the decimal just ends. Yes, it just ends. Oh, and also remember that the the other numbers are irrational numbers, and these repeating decimals, they're actually rational numbers. But things that don't repeat, like pi, it's considered irrational. But it's still part of the whole real number group, although it may not seem so. The imaginary numbers, a plus bi, is considered outside of real number territory. Okay? Okay, now let's move on to algebraic properties. But first, we're just going to talk about some basic properties, like the commutative property of addition and the commutative property of multiplication, which means that when we're adding two numbers or multiplying the two numbers, the order of the numbers do not matter for the correct calculation. AB equals A. Sorry, guys. Sorry. Okay. Well, let's do this again. So, commutative property of addition / multiplication. This means A plus B equals B plus A B equals BA. So, to commute means to move around, right? Move around. Which means that we can move the order of the numbers around and it does not affect the result. Do you get it? The root word, guys. The root word. It relates. Okay, guys. Let's move on to the next one, which is the associative property of addition. Let me just write that down, guys. Associative property of addition and multiplication, guys. It means that any three numbers, A, B, and C, for example, whether or not they're in parentheses, well, it's more likely it's just in parentheses, guys. It means that they'll always be the same. For example, like 1 plus 3 plus 6 equals 1 plus 3 plus 6, but they're in parentheses. So basically, this proves that they're both 10, right? The same goes for multiplication. I will not explain that because it's just in the same format. The next one is about the distributive property of multiplication over subtraction. Let me just write that down. Distributive property of multiplication over subtraction. It means that we get the same number when we multiply a group of numbers subtracted together when we multiply each number separately and subtract them, which means that A, B minus C equals A, B minus AC. Yeah. So, it's very simple. It'll be 20 minus 14 equals 6. We can prove this by doing 2 times 10 minus 7 equals 3, which equals 6. They're the same, right? It can just be proved that easily, guys. Yeah. And this can also be over addition, but it just changes like that. And yeah, that's pretty much it, guys. We can also do like A, B plus C minus C equals like AB plus AC minus AD. Is there any case that this doesn't work? No. It works all the time. So remember these three. The first one is commutative property of addition/multiplication. The second one is associative property of addition/multiplication. The third one is distributive property of multiplication over subtraction/addition. Thank you for learning with me.